So I do have a PowerPoint for this lecture. I can't remember. Let's see how long it is. It's 14 slides. It's up on Canvas right now. It is really not too in depth. Um, I'm probably just going to really just blow through that first, just because it's not very helpful. I would say that actually watching a part get drawn out after you create the part and then you transfer it into your into the e-drawing. I think that's going to be a lot more effective doing it that way. So I'm going to be not really utilizing SolidWorks too much until once I'm done with the lecture, which really shouldn't take much more than like 20 or 30 minutes. So I know that some of the stuff might not make too much sense right off the bat, but just bear with me if you do have any questions about anything regarding the the PowerPoint, then I'll I'll go through any of those things if necessary. Cool. Um, so for anybody who is just joining right now, basically we're just going to kind of quickly go through the PowerPoint super fast. It's not going to be anything too crazy. Like I said, it's about 14 slides, so we'll just go through that. Bear with me, and then after that, we'll kind of go through dimensioning and go through some of the features of what is it? Of actually like dimensioning and creating a drawing for an actual like part. Um, so yeah, let's get started. Why not? And spoiler alert, the part that I currently have on stream right now, that's what we're going to be doing the drawing for. Okay, so we are going to be talking about engineering drawing. So kind of a little recap on what we talked about way earlier in the semester when we were just going over basic sketches. Um, so a lot of these things kind of a lot of the ways that you do dimension um, a general part and kind of define all your sketches, you're going to do relatively similar stuff with your engineering drawings as well. So kind of a recap of some of those things that we had talked about then.
Okay.
We want to make sure that all of our parts or all of our lines or any measurements or any of that stuff, uh, it's all of it has some sort of meaning to it. So no line is going to be drawn that doesn't have any meaning whatsoever. It would be kind of silly to add extra lines when we don't actually need them or anything of the sort. So we're generally speaking always going to try to reference lines that we can either see or reference lines that make sense to have drawn there in some capacity. So like I was mentioning, if we're following along just on the PowerPoint, the two different sheet types that we're going to go through are going to be the ANSI and ISO. So ANSI just means that it's stands for American National Standard Institute. So kind of on the diagram that you can see on the right hand side, you'll see just a diagram that basically just shows different letters. So those lettering or letters are going to kind of designate the size of the paper. So I guess you could say that the general rule of thumb for an ANSI drawing or a drawing that is being made on an ANSI sheet is that if it's a letter further in the alphabet, then it's going to be larger. I genuinely don't know if there's ones that are bigger than E, but A is our standard 8.5 by 11 inch sheet of paper, and then you can get things that are even larger than that, like a B size sheet, which is going to be like a ledger. So that's kind of more of like a landscape view. C is just like a much bigger letter size, and E is just that same thing, even scaled up further. Similarly, and you'll notice a very similar distinction here, the ISO sheets look very similar. The only difference here is that the uh, kind of the format on how these are labeled is a bit different. So basically for this one here, it can go smaller than that general like letter size, which would be the A4 for an ISO. But generally speaking, we're probably going to want to use a sheet that is anywhere between, excuse me, A0 to A4. A0 is pretty darn big. That would be that entire image there, I'm guessing, and we can kind of verify that once we actually start getting into drawing sheets. But by and large, we're typically going to use things that are probably between like an A2 to an A4, maybe a little bit bigger depending on what we're actually working with, how much detail we need to put into our diagrams. So ISO versus ANSI views, the views tend to be a little bit different, but you can see just in terms of the projection. So if we're kind of breaking down like a first angle projection versus a third angle projection, then you can, if you kind of look at like that second from the bottom diagram, uh, essentially you, the viewer, if you are looking at the object, then it kind of depends on whether it's the first angle projection or the third angle projection. In the case of a first angle projection, you are looking directly at that part, but then the projection of that part and the direction that you're looking at it is basically being projected onto the sheet or onto a specific view of the sheet. In the case of a third angle projection, basically the location of the projection is between you, the viewer, and the object. So don't worry, I'm not really going to test you guys on any of this stuff, but I will ask you guys to kind of have a general idea on very basic things to be adding to your sheets. So there's a couple things that baseline should always be added to your sheets, and then some other stuff that we'll kind of talk about a little bit later. So a lot of this stuff is just kind of little bits and pieces of details that you don't really need to take to heart too much, but there are some things here and there that I do want you guys to remember and be utilizing in your engineering diagrams. So in terms of sample views, I have here just a diagram. It's a pretty good diagram. So really all that's going on here, and the ones that are highlighted are, I guess you could say, the standards that I want you guys to have. So if you have an isometric view, that's kind of the view that I've typically been giving, the one that shows the model view, kind of that high quality visual, so it's not looking at it from a very specific face. It gives you a more detailed picture of what's going on with the part as opposed to just a one-dimensional view for it. We also have a top view, front view, and right view. So all of these are the views of your very basic datum planes that we originally start with. Um, so we always want to have bare minimum those four things when we're working through our engineering diagrams and drawing. So we want to have our isometric view just because it's really nice. It gives us a little bit more perspective as to the part. Sometimes not having an isometric view makes it a little bit trickier to actually see what's going on with regard to the part. Additionally, we want the top view, front view, and the right view. And it's generally speaking given in that order as well, where we have kind of that front view that's being diagonal from your isometric. Then you have your top view right above that, and your right view crazy to the right of it. We can also add other views as well, and a lot of these can be very helpful depending on what we're doing. Things like section views. I know a lot of you guys by this point should be relatively familiar with that. So section views are really going to just encompass, well, maybe I'm looking at a specific region where I took a knife and I cut this object in half. And then I'm looking directly at it from some different perspective. Those are helpful. Detailed views as well can be very beneficial as well. So basically, a detailed view is going to allow you to take a specific section of your part, specifically of a given view that you already have, basically blow it up, give a larger scale to it. We also have auxiliary views, which pretty much just allows us to take an edge and look at that part at that specific edge, basically normal to that edge. So it's kind of a little bit hard to see, but if you look at the diagram in the very middle, basically they clicked on one of those diagonal edges, kind of the one on the right hand side, just to the right of the through hole that goes directly through the guide there. So that would be an auxiliary view. It's basically giving a better idea of what's going on with the holes that we have there, as opposed to literally just drawing it maybe all on the right view. Because generally speaking, we like to be labeling things when we're looking directly normal to that view. Um, so then we also have just some details about precedence of lines. So just basically kind of giving a breakdown of how you should kind of be formatting your lines, or in terms of, generally speaking, what you should expect to see in a relatively orderly fashion, excuse me. So we want to make sure that visible lines or features for an object are readily apparent. Anything that is hidden can be seen through a dashed line, and that's not always necessary, but it can be very helpful depending on the complexity of our part. Cutting plane line, so anything that is designating a cross section or perhaps a center line, those are always important. Break line, so it doesn't really show it on this image right here, but anything that's kind of breaking up the image a little bit or breaking up the part or the drawing of the part to basically save room on space. And I can show you guys a bit of that as well a bit later. Your dimensions, you want to make sure that everything is dimensioned properly. Uh, your leaders as well. So when I say leaders, I'm talking about the lines that are going directly from a measurement or information about a specific part to either an edge, another measurement, some sort of point of interest, anything like that. Uh, that's kind of the basics just with regard to precedence of lines. So just things to consider when you are dimensioning and just adding more detail to your engineering drawings. I go into a little bit more detail here about kind of the two types of dimensions that we can have. So location dimensions, which those are, let's see, so it says locates a horizontal position, vertical position, center of a hole, or other model features, or size dimensions, so provides horizontal position, vertical position, angle, diameter, radius. So size dimensions, you can think of kind of like what it says there, things that are going to be arcs, radii, diameters. Location dimensions are going to be based upon some sort of reference point as well, but those are also going to encompass things like centers of holes, chamfers, because, I mean, if you think about it, things like chamfers kind of depend on maybe perhaps which side it's in reference to. So kind of going back to what we were talking about before, chamfers can be composed of both, rather, either an angle and a linear dimension, or two linear dimensions, or even two different angles. So you kind of need a reference point, hence the location aspect of the location dimension. The dimension types, those are also important. So we haven't really touched on it too much, but we will have to kind of touch on it a bit more now when we're starting to point out specific dimensions in our drawings. We might need to be a little bit more specific with how we're smart dimensioning things. So you'll notice that just using a basic smart dimension on a chamfer typically doesn't cut it. Uh, because kind of like what I mentioned, I mean, it depends on what the reference point is if we're considering an angle. I mean, you have to ask the question, okay, there is an angle from what? So where is that angle originating? So those are things that we need to consider when we're doing some of our smart dimensioning. So just some things to keep in mind whenever we are creating our drawings. We always want to make sure that there's some form of a title, units, material labeled. So just as kind of how I give you guys the material, the units that we're using here. I even give the mass, which technically isn't that necessary, but it does help because it can, as someone who is trying to make a specific part, gain a better idea of how to actually make that part, or if their measurements are even remotely correct. I mean, if they don't have the correct mass and it's not like within a reasonable tolerance, you could perhaps say that your part is not actually what it should be. Also, yes. I'm not. So I am doing a screen share right now, but I'm not actually utilizing SolidWorks at the time. I'm just going through the lecture right now. I am on slide 9. So if you want to just grab the PowerPoint on what is it, on Canvas, then you can follow along there. We're going to be dipping from this pretty soon anyway. So let's see. So other things to consider, kind of like what I was saying, try to have an isometric view as well, which is kind of harkening back to that 3D view, or any other kind of detailed view, projection, sections, anything like that. Um, Also kind of making the decision as to whether or not you want to show specific hidden lines. Sometimes there are times where you do want to consider uh, hidden lines, and other times that you might feel that it's unnecessary, perhaps for the sake of not cluttering up the image too much. Providing a good scale, so we'll talk about scale, arrows for section, we'll talk a little bit about the arrows for sections and cross sections, a BOM or a bill of materials, BOM. We'll talk more about that when we start getting into assemblies, but most of you guys have already technically seen that if you did the last homework, or if you've at least started working on the last homework. The bill of materials is really just that table that dictates, hey, you have such and such number of these parts or components. You have this many screws, this many Lego heads, or whatever the heck you're working with. So it's really just a breakdown of showing you, do I have everything that I need, at least readily apparently labeled in my diagram right now. If you've added center lines or center marks, so making sure that there's any sort of symmetry if there need be, or any sort of center marks for holes. All the dimensions that you would need in order to manufacture the part. So this is kind of talking more about some other more advanced details, like if you need anything like any specific welds, um, any other details like that, maybe perhaps other dimensions that are related to either parts or assemblies, that if you were to try to manufacture this, could you be able to do it with the dimensions that you're given? And also, generally speaking, and I know that I'm not always great at this, so hopefully I've done a reasonable enough job, but just making sure that everything is easy enough to read. I mean, I'm sure you guys already know, I mean, especially if you're considering like the exam or anything like that, there's nothing worse than a ridiculously cluttered diagram, because then you need to literally go on a treasure hunt to find one single measurement. And I mean, obviously for an exam, that's a problem, but even if you're just considering if you're trying to give someone a diagram of what you want machined, or perhaps somebody gives you a diagram that you are trying to machine, well, can you even read all the details there? Is it able to be put together in a reasonable way where you can look at the diagram and just say, okay, this measurement correlates with this correlates with this makes sense. Here we have a chamfer, fillet, whatever, any of those sorts of details. So obviously it's not going to say specific features about a lot of that stuff, but it will give a pretty good breakdown of other details, kind of like what I just mentioned, fillets and chamfers, possibly welds, which I doubt we're going to do any of that, but any of those sorts of details definitely need to be easy to read if you're trying to give or get an engineering diagram. Things to not do that often, and I know that I'm a culprit of a couple of these, so hopefully we can always try to keep these to a minimum as best as we can. Dimensioning 3D views, so things like an isometric uh, view or anything that where you can see more than one face. We generally don't want to dimension those things. It's a lot harder to dimension. Anybody who did the what is it? Who did the extra credit opportunity assignment knows that it was probably a pain at some points to seriously pick out some of those measurements because they're so fine tuned to what you're trying to look at. And SolidWorks doesn't always do a fantastic job at being able to label things. It does a really darn good job, but it's not always amazing. Dimensioning hidden lines. We don't always want to dimension hidden lines unless it's absolutely necessary. And even then, we'll try to steer away from it, because if we're trying to build the dimensions for just one two-dimensional view, it doesn't make sense to add another plane behind it and start dimensioning things behind what we're already looking at. Overlapping dimension lines, so try to make sure that you don't have two dimensions that are like right on top of each other. I mean, obviously, I can show you kind of what I mean by that a little bit later, but by and large, I think that's pretty self-explanatory. Leave views as solid material. Um, I'm not entirely sure what that one actually means, if I'm being completely honest. Solid material, exception 3D views. I think it just is talking about kind of how the views actually look. So we'll kind of see that. I mean, if most of you have kind of been keeping a close eye on the engineering diagrams in general, generally speaking, the isometric view, the one on the top right, is the only one that actually looks like it has some structure to it. All the rest of them are just going to generally be a two-dimensional drawing. We'll try to keep those ones as just being the lines themselves, not colored in or anything like that, because it makes it harder to read. Um, this is also a big one as well, making several views that are relative to nothing, either relative to nothing else or are just unnecessary in general. Use projection views as much as you can, but try not to overdo it. Sometimes there are instances where more information is not necessary, and it can possibly be detrimental for fear of just cluttering up uh, the page more, or your drawing rather. And also try not to change the names of your parts too much, or specifically ones that you might download. But I mean, if you're adjusting parts or names of parts, that's fine. But sometimes there can be a conflict between the part and the drawing if you try to make adjustments to the name. So try to make sure that if you're naming something, at least once you end up opening it back up or open it up as a drawing, that's what you want it to be named. The only reason that it points out downloads is just because sometimes if you get something off the internet, if you change the name of, say, the part, but not of some other details, sometimes it might be a little bit finicky in the drawing. So try to keep things at least relatively consistent. So a couple examples, or rather a example, and this one will be familiar a bit later. Um, But I mean, if we kind of take a look at this drawing and consider some of the details that we talked about before, um, I mean, this one's relatively. I mean, it has some parts here and there that are good, but it also has other stuff that you can clearly see this just looks not fun to work with. I mean, first and foremost, I guess if we're to start anywhere, there's a lot of places you could start, is that we have a detailed view of the isometric drawing. And those are all just a bunch of angled measurements. So I mean, it's hard to pay attention to if it's even supposed to be the correct measurements. I mean, it's hard to determine what that even is. Like that kind of cutout box in the corner, they're all the same measurement, but we're just kind of hoping that those are actually what the length, width, and height of that small cutout is. And then, I mean, I didn't even notice it. I don't know how, but the most glaring of which probably is the fact that you just have a box that's right in the center. That doesn't tell you anything. It's not even dimensioned. It has no details to it. That one in the middle, that gray box in the middle, is completely meaningless. It's not useful in the least. Some other details is that, I mean, it's nice that it gives us some section views, but if you look at that kind of middle left-hand one, you have some overlapping stuff. Section BB, it's hard to determine where the section is even being done from. And you have a lot of cluttered measurements. You do have a nice section view kind of up top, section Z. If I'm being completely honest, I don't even know where that's being originated from. So it's hard to determine, like, okay, we have a circular center to it, but like, what the heck? Where is that section in reference to? So when we typically do section views, it has to be in reference to another view. Another detail, probably the last one that I'll even go over because I'm sure we could find a million details on this to beat into the ground, but like there's a bill of materials at the top right, and it's totally empty. So that's doing literally nobody any good. It's not helpful in the least. So it's totally useless. No reason to have anything like that there. So kind of going back very briefly to what I mentioned before, sometimes it's better to have less information than more. This right here is a pretty good drawing, so, or at least the next one, sample drawing. So this is slide 11. So it does have a lot of details here, but by and large, the majority of these details, there's not really a whole lot of overlap here. It gives a lot of the dimensions fairly clearly. It gives us section views when it is necessary, and it specifically shows us, I'm trying to at least see where it is. Yes, so it does tell us where certain section views are located. So section AA is kind of around like just to the middle left of the page where you have those two arrow bars with an AA. It's giving us a lot of information with regard to chamfers, with regard to what those degrees are, any sort of cutouts, all of that information. It does give a bill of materials, even though there's only one item. And I mean, unfortunately, this drawing is already hard enough to see how it is. It's probably like 20 years old. But it thankfully does give us a whole bunch of information here that, for the most part, one would be able to replicate this part fairly easily. One little detail that might be a source of confusion that I'll just point out right now is that you kind of see that it's two parts. Like the middle drawing, it has this little like cutout part on the left part, or excuse me, on the right part of the shaft. So really all that's doing, that's just a breakaway or like a cutout region. So cutout regions are kind of a nice little way of saying we know that there's a lot of uniformity in a single direction, which means there's no reason for me to have the entirety of this diagram on the sheet. So I can kind of simplify things a little bit while still maintaining the integrity of the drawing. And I'll explain that in a little bit. The shaft that we have currently in SolidWorks on my screen share, I'll be able to show you kind of an example of that. All right, so the last three slides are actually talking a bit about some of the uh, some of the specific things that you guys will be using a whole lot. So I won't really spend too much time on these ones because we'll be going into as much detail as we can about all these. But in the drawing tab, we have things like projected views, auxiliary, section views, removed section. I didn't label that at all, but I will use that, and I'll show you why that is a really cool feature. In detailed view is also really great. In the annotations tab, I took a screenshot of it, and you can't even see the annotations tab, but it's basically like two tabs down. Smart dimensioning, just like how it is in just normally making parts, has a lot of different ways that you can dimension things. And it has even more when we are dealing with trying to annotate our figures. Um, so definitely look at these. Don't skimp out on them. Actually look at all the different things that you can do with your smart dimensioning. I mean, genuinely speaking, there's a handful here that I have no idea how they work. Like a lot of things that we've gone through before, there's many different ways that you can skin a cat, many different ways that you can create these parts or components and label diagrams. So play with stuff. Don't just try to use one thing and consider it always reliable. There will be times where you're trying to mess around with different parts or perhaps create drawings and one thing just doesn't cut it. So you're going to need to branch out from time to time. The balloons and auto balloons, that's basically just a way that you can kind of smart dimension assemblies a little bit better. We'll talk about that more next week. Um, the hole call out, which is basically the way that you can take any holes, either whether they be extrusions, specifically Hole Wizard. It's very good when you're using it with regard to Hole Wizard, and being able to give all the details for that specific hole. Center marks and center lines, a lot of those things will just default be there in your figure when you kind of create a specific view of it, but they're always good to add if you notice that it's not actually there. Center lines are great because it's just giving you a way to see where there is a line or plane or axis of symmetry. And also the area hash fill, which just kind of gives you a little bit more control over regions that are actually cut out. So perhaps when you're doing cross sections. And really the last one that you will use sometimes will be the sketch tab. So just like in regular, like the parts section for SolidWorks, you can create more sketches that are actually on your drawings itself. So this won't really create new geometry, but it's a very good way for you to create reference geometry. And the reason I say that is because sometimes you might notice that there are certain things that you know that you created on the part, but it might not readily show up on the diagram. Perhaps you're doing a cross section of something, and part of that cross section has either a circle or an arc to it. Generally speaking, it won't have a center to that circle or arc. Um, so, I mean, in instances like that, you might want to add a center just for a little bit better control over kind of how you're dimensioning things. Um, so kind of leading into the next one, try to limit the number of additional sketches you are going to add to your engineering drawing. I mean, remember, the idea here is that with engineering drawings, and with parts as well, but definitely with the drawings, you want to make sure that everything that is there is relevant. If you're adding more stuff to it that really isn't relevant, it's just going to confuse whoever either you're trying to show this diagram to, or it'll confuse you if you end up getting one that tends to have just a ton of different drawings, like extraneous drawings or extraneous views that you just really don't need. Um, yeah, so that's really about it with regard to the PowerPoint. And that's pretty awesome for whatever reason. Does it say that I'm not streaming anymore? That's pretty cool, I guess. So let me actually go to the stream now. I guess I'll just refresh it because Discord just decided to nix it. As soon as I find where it is. Cool. So while I pull this up, does anybody have any questions about like the PowerPoint stuff? And I know I already said kind of near the beginning, just kind of bear with me. A lot of this stuff will kind of make a bit more sense once we're actually doing some smart dimensioning and kind of getting an idea of what sort of stuff we're doing. Okay. All right, so let me hopefully get my stream back up eventually. There we go. Alrighty, so the stream should be back up. Sorry, it went down. Discord decided to be dumb. It happens. Alright, so let's see. So, I didn't really go too much into detail regarding this part, but this is just a very basic rod that I made. I'm actually going to add a dimension to it, or not dimension, just a part material, excuse me. So I mean, you can probably see all the different features that I use, but I basically just did a revolve to create this. I added a couple fillets, or rather a fillet on one side, a chamfer on the same side. There's a cutout here, and maybe if you guys kind of saw it, I went super quick. There's actually some stuff on the inside here as well. So it's hard to see, but if I do a cross section, you can see that there's actually a circular, kind of like a donut region that's cut out of this as well. So these are all things that you do want to kind of consider when you are making a drawing for a part. So I would say one of the most important things that you guys want to consider is that if you are not the one who is making the part, you better have very good understanding of the part if you're going to make a diagram of it. The reason for that is because If I never mentioned anything about that internal region, that would have totally gone unnoticed. There would have been no way that anybody would have been able to see that unless this part was moused over, unless somebody moused over kind of the revolve and was able to actually see what the heck is going on in the center there. You look at a cross section and then all of a sudden, holy cow, there's actually some stuff on the inside here. It's just a circular region that's cut out of it. So now that we have a relatively good understanding of this part, and obviously we can kind of take a couple moments, look at all the different dimensions so we can see, hey, we have a 5, I believe I'm doing millimeters here. Let me just make sure I'm in the correct mode. Like a 5 millimeter cutout right here. That is 5 millimeters from the edge. We can get all the dimensions, or we can see all of the different dimensions of the sketch right here. And I know you're probably yelling at me because a lot of this stuff kind of does look like it overlaps a whole bit, so bear with me. This is just the the part itself. It's not the drawing. And this part here is up on Canvas. I'm like 95% sure. So if you guys want to go and download it and open it up, you are more than willing to follow along. I'd rather you guys do that just so that you guys can get a little bit of practice. Because I know I suck at just watching somebody do something and then I'll try it later and I'll be like, I have no idea what you just did there or how to do it. So first things first, if we're going to really open up our drawing, we can do it in two ways. If we already have a part, then if you are in the menu for that part, or rather if you are looking directly at that part, then you can look at the specific part and just go down, and one of our options here is make drawing from part. Another option is if we just hit new, then we can open up the drawing interface, I guess you could say. But I'm going to do it specifically from here. You should get prompted to choose a specific sheet format. It will look something like this. For whatever reason, mine just decided to stop doing that, which kind of annoys me, but so it goes. If you ever do want to adjust your sheet format, you can just go to this bottom left-hand corner, and when you cancel that for a second. If you right click and hit properties, it'll allow you to change the format. So currently I believe it's just on the ANSI landscape, which this one is, as it shows right here, height 8.5 inches, width 11 inches. So fairly standard for what we're doing here. But I might choose something different. Maybe I'll choose definitely not an A0 because that would be huge. But let's choose, let's choose like an A4. Let's choose like an A4 landscape. So if you haven't already chosen one yet, you can choose that A4 landscape. If you already did, you can go to this bottom left-hand corner, hit properties, and then you can hit what I hit, which was an A4, yeah, an A4 landscape. So now you'll see, you might see some stuff on the right. There might be some stuff on the left as well. So occasionally when you do start out, it might prompt you to input parts. If you have that menu, then it'll probably look something like this, where it says model view at the top. If you are deriving a drawing from a part that you just created, then it'll generally speaking be in this menu right over here on the left. Otherwise, you should have some other views that you can choose from on the right-hand side. This view is from this view palette, so that's fourth from the bottom, and it kind of looks like the 2D drawing diagram. I tend to like this one, just because I'm able to immediately drag and drop parts into my interface. So what I generally like to do right off the bat, I'll put my isometric view in there just because it'll give me a good semblance of what kind of part I'm working with here. And for these isometrics, I also like to choose this second from the right option, shade with edges, because it gives a very good idea of what we're looking at. But even right now, we can tell that it's pretty small. I mean, even if we zoom out and we're kind of looking at this, I'm pretty sure this is still kind of like an 8.5 by 11 sheet. It's just landscape. It's hard to see. So I might want to bump things up a little bit. So there's two ways that we can do that. If you go to this bottom right-hand button, you should see something that gives a ratio. So mine says 1:5. That's basically saying that I can't think of a really good way to describe it, but basically, if it's a ratio that is less than 1, so in this case it's 1:5 or 1/5, that just means I believe it's pretty much just saying that this is 1/5 of what the actual size would be. So it's relatively small. We might want to bump that up a little bit to say 1 to 2. So now it's pretty big. We might need to adjust some of the sizes a bit later, but this could do for now. We also, if we wanted to, we have a scale option on the left-hand side. So we could use the sheet scale, which is whatever the heck we choose down here at the bottom right, but we could also adjust the scales differently per whatever kind of uh, thing we might be working with. So sometimes some drawings might need to be smaller than others. We might not need to use the entire drawing there, or rather a 1 to 2 or 1 to 1 drawing. So sometimes we want to either scale things up or scale things down. And then it says that the palette is out of date. So if you just hit this little circle or green arrow button, it refreshes it and allows you to pick more. It also shows you which specific ones are already in the sketch. So you can see this little thing here, this little kind of symbol with a green check mark. That's really just showing us that we actually do have uh, our isometric view into it. Sometimes current or dimetric or trimetric might be helpful, but isometric usually is one of the nicest. That's kind of like looking directly at the origin with the X, Y, and Z axis kind of moving outward, respectively. So from here, we can add more views if we want. If I want to, I can just start dragging views just onto that sheet. But I want to also use what we have up here. So we have model view, which allows me to kind of just pull a drawing in. I think I can just double click it and then click it right in. And this is going to give the front view automatically. So the standard views allows me to change things accordingly, as you can see. So this is just showing all the different kind of orientations that I could show for it anyway. But I'll typically choose this bottom left-hand corner to be the front view. Another way that we could do this as well is if we use the 3 standard view button. 3 standard view is going to do pretty much what you expect, and just like what we were talking about before, it's going to add the top, right, and front view to our diagram. So I think if I just hit OK, then it does it automatically. It already puts all 3 of them. And you can see here, they're already linked up accordingly. Now, that's not to say that I couldn't do it for one of these. If I bring this in and then I kind of put it in line with how it should be, it'll automatically assign uh, where that specific drawing should go. So all you really need to do in an instance like that, if I wanted to kind of get rid of these guys, just to, oh goodness. If I were to kind of just do it by hand rather than using the 3 standard view button, I would choose my front to be over here. I'd probably scale this down a little bit, so I'd go for the 1 to 5. And maybe we will make this 1 to 2 just to make it a little bit easier to see. So we have that view. We also want, why does it say front and top? That's weird. I'm gonna get rid of that. So we could have front, and then if I just hover top over it and hover right to the right of it, they'll automatically kind of get in relative line in accordance with how they should be. So I'm going to go back on this, and I'm just going to do the 3 standard view one more time. I know you guys are probably getting sick of me Control-Zing, but it's fine. So this is nice because then anything that I do to this, I can adjust it automatically for all 3. Basically what's happening is it regards the front view as the parent. So you can set it such that anything that happens to the parent view will also happen to the children views as well. And this view is pretty nice, or rather this size is pretty nice because it gives us a whole lot of perspective as to what's going on. So what I'm actually going to do, I'm going to make this sheet a little bit bigger. I'm going to make it easier to see some of this stuff, or rather give us a little bit more room. The stuff down here is kind of taking up more room than I want it to. So we can go to properties, and we have this set to, if I remember correctly, it was a landscape, A4. So I'm going to bump it up to an A3 and hit apply. So now we have a whole bunch of room, and this is a whole lot better. So this kind of gives us a whole lot more leniency and ability to kind of play with our drawing. When I click make drawing, so you don't want it to be an assembly. Or do you mean that you still have the part? Are you trying to open just the part itself, Miranda? And you can technically browse as well, so just make sure that the part is in the respective place that it should be, or just you're finding the part in the correct location. Let's see. So what I would probably do right now is I might just start adding some dimensions to some of the stuff here. And let's also not forget that um, we did have some stuff that's on the inside here as well. So a cross section is going to be warranted. There's a couple different ways that we can do that, some of which are not going to be entirely necessary, but some of them will be kind of important to use or could be important. Let's see. So let's start dimensioning some things. So the view layout just has a lot of stuff that the drawing tab does. I don't think there's anything in the view layout that is not already in the drawing tab. So let's just go to annotations. So just as like you would expect in just regular, like when we're messing around with our parts, we can uh, smart dimension things accordingly. So if I smart dimension this edge right here, even though from a three-dimensional point of view, this is not a flat edge. From a two-dimensional point of view, the projection of this is just a totally straight edge, which means I can just dimension it totally fine. I can slap that right there, and I'm probably going to make this millimeters. We said that it was the first time around. And then I know I kind of talked a little bit about chain dimension, so I don't even know how it works. So let's kind of figure it out. So I don't think that's how it works. But I think basically what you're supposed to do with the chain dimension is you can kind of click from here to here, and let me actually click it one more time. To you, to you, to you. Yeah, there we go. So that's super cool. So if you have that, I mean, I figured that's what it did, but I was not aware that you could just do it so easily like that. So chain dimensioning allows you to pretty much just designate specific, I guess you could say, stopping points or other regions where you do have parallel lines, and then just go from one to the next. And it creates a nice dimension where we can just say, hey, I'm good with all this. Everything is dimensioned properly from one edge to another edge. So it's a really good way of being able to just immediately dimension things from one side to another, whether it be up and down, left and right, however. Um, Sticking with that same idea, we also have this second one from the bottom, a chamfer dimension. So I know a lot of people, maybe on some assignments, were getting maybe perhaps a little bit confused with kind of which edge really to chamfer from, or if it was even necessary to flip, if it was necessary to kind of flip from one edge to another. So that is kind of important. So back to what I was saying before, we always want to make sure that our chamfer has a reference point. So I might say, well, I know that this is the edge of the chamfer, but it hasn't created anything. And that's because it says, okay, well, sure, I know what the length of this is going to be, but what should the angle be with respect to some specific other edge? So I could choose either of these two edges and it'll give me those details there. So if I click on this edge now it says, okay, it is a chamfer with a distance of 2.5 millimeters and a angle of 45 degrees. So the nice thing about this one is that I could have technically chosen either edge. And if you were to create this on your own, if you were to flip it, wouldn't matter. It's going to be the same either way because 45 degrees. However, if you do get things that are perhaps like 20 degrees or 50 degrees or 30 degrees or anything like that, those ones you will need to be a little bit careful of, not just by creating your part, but also just by making sure that the orientation is correct. So you always want to at least be a little bit careful about that. I'm just going to go back to the basic smart dimension, and we'll see here that we have a fillet. So kind of like what we've talked about before, we can, or rather, if we have some sort of R value, definitely an R value right next to a curved edge or an arc, it's typically indicating some kind of a fillet, more often than not. And then I know that this kind of looks weird how it's slanted like that, and some of you guys might be getting that as well if you are following along. Don't worry, we'll kind of go into some of those details. So you might already be looking at all this stuff that's on the left-hand side here, and we'll get into a little bit of that. Specifically values and leaders. Other has some good stuff in it as well, but primarily the first two. So we're doing a pretty good job of mentioning these sorts of things. I know how long this shaft is supposed to be, and I also know some details about some of the edges. I know that this one is just a 90-degree edge, 90-degree edge. This one has a chamfer, and this one has a fillet, but I don't even know how, like, I don't even know what the radius or diameter of these sections are. I have no idea what they are, so I'm going to have to create some dimensions for that as well. So one way is that I could literally dimension this other view of it. So if I want, I can add dimensions to both, but this is also fairly self-explanatory as well. But let's actually do this one first, because it's not as self-explanatory. Um, yeah, we'll do this one first. And before I even do that, I'll do that. I'll do that with this instead. We know that this has symmetry throughout the entire thing. This entire object is totally symmetrical from one end to another. So the chamfer is symmetric, the fillet is, the part on the inside is radially symmetric, I guess you could say. So everything here does have some form of symmetry. So you'll see that I hit the center line tool kind of on the right hand side of the annotations menu right underneath center mark. So really what we need to do with center line is the idea here is that we can't just pick something like specific, like where I want it to go. I need to pick this, I guess, reference points. Uh, you could say like the end points of where this center line will be. So I know that my center line is going to be right in the middle of all of these, like these top lines and these bottom lines, which means I can pick any group of the top or the bottom lines, though I do want to make sure that they are kind of intelligently placed. So I'm just going to choose these two here. So I'll choose this bottom edge and this top edge, and it immediately puts in a center line. And you'll notice, yeah, it is a bit short, but we can actually change that. When you click on the center line, you'll see these kind of blue squares that are on the side. If you click and drag those, you can just increase the distance of them. So that looks a whole lot better. Now that's showing us that there is some kind of symmetry going on here. So kind of the details that are listed here on this front view are, for the most part, plenty good as it is. We don't even need to go into much more detail about this diagram right here. So let's go into this one. And there's a couple things we might want to add. One thing that we want to probably clarify is I don't know how large these cylinders are. I don't know what their radius or radii are, or diameters, whichever. So what I can do is I can just smart dimension from one edge to the other, and you'll notice something pretty cool here. It's not giving a distance, it's giving a diameter, which makes that actually a whole lot nicer because true, from a two-dimensional standpoint, this is really just a box, or rather a fancy box. But now that we kind of have a little bit more, after having smart dimensioned it, we can see, hey, this is not just a box. These things have cylindrical, like, have some cylindrical component to it. So it's a little bit more than just that, which is fairly nice. And again, I know it was bad before and it's worse now that now we have to kind of look at these things by tilting our head 90 degrees. So let's actually fix that. And I'll kind of show you something pretty cool. I'm going to actually move these down a little bit. So if you just click and drag the numbers themselves, you're able to just drag them all to wherever you want. So I can put it out here and you'll see that the arrows are pointing outward now, or rather, yeah, they're outward towards the lines that are there to kind of get a better idea of what's going on between those two measurements. If I put it in between those two lines, it'll move the arrows just to make sure it's not conflicting. I can move it all the way out here and you'll see that these lines are extending even further, so it makes it a whole lot easier. How do you make the dimensions horizontal instead of vertical? Haha, exactly. I was just going to get to that. And so it automatically registers that due to your prior dimensions. I believe so, if I'm understanding your question correctly, Miranda. Yeah. Basically, it's even though from a 2D view, you can't see that it is cylindrical, SolidWorks understands that it is a cylindrical part. So there's no need for you to add extra information to it if it's already adding it there anyway. Now, let's actually get into kind of what I want to at least point out to make things a little bit easier to read a lot of this stuff, because I mean, this is fine. I mean, it's relatively simple enough to read, but if you have tons of different measurements, I don't want to be tilting my head 90 degrees just to be able to read all this junk. So we can see a whole lot of information on the left-hand side here. We have something for value, and we also have liters as well. So in value, this is giving a lot of information with regard to the specific values that we are given here. No duh. But there's a lot of good information here. So tolerance is just going to go into the details of maybe how many digits you want after your number. Most of these default to the hundredths place. However, if you have very specific measurements, I can change it to be even more than that. So you just need to click the drop down menu and it will go to, I mean, what is that, 8 values after the decimal place, which, I mean, if you need that much tolerance, you got it, but that is a hefty amount right there. um, you can also override the value. Sometimes SolidWorks might put a specific value there that might be rounded to something that might not be exactly what you actually want it to be. So if I actually wanted this to say, well, I know that it's 1.49 and I need it to be a very specific measurement, but it's rounding it up, I could change that to, I believe, in a manner like that. So it's still saying on the diagram, or at least on the part itself, that it's 1.49, but you are, in this instance, saying, I want to edit that just a little bit. I want to change that up. I don't think that that is the specific measurement that I want it to be. I don't really know too much about styles, so it's really not that relevant. Um, and some of this stuff relating to the different tolerance and precision uh, options, I don't really play around with this too much. You're mostly going to play around with this second box here, what the tolerance of your, or rather, I guess it's saying your unit precision specifically, and the dimension text as well. So sometimes it might not give enough information that you want to actually add to it. So for specific holes, it might not say, hey, this actually goes through the entire thing. I might want this to be a through all hole here, or perhaps I want to designate other information. You'll also see some symbols here where I can, if it doesn't already put it, I can put, say, a diameter, or perhaps a degree symbol, or maybe I want to have just a specific tolerance to this without actually giving a specific value. Maybe I know that 1.5 millimeters is a pretty darn hard measurement to actually get. So I'll say, well, it could be 1.5 with a tenth of a millimeter tolerance there, or even more so, a quarter millimeter tolerance. So other information there that might be relevant to your diagram. You also see some other symbols here, like our countersink or counterbore, as well as depth. So pretty much everything that SolidWorks can do in order to do a specific call out, you can add those aspects there as well. Um, let's see what else. So let's go on to leaders, which this is kind of what I mess around with a bunch here and there. So for any sort of arc or circular dimension, you'll typically get a lot of this stuff up top here. So you'll see right up here, it allows you to kind of designate specific things. So maybe I want this to give a diameter value, don't know why, but a diameter value for this fillet instead of a radius. So I can do that, and it'll just basically show me where the other end of that will be and kind of where the center of a circle of diameter 3 would be. Now, for something like a fillet, this isn't optimal. We typically want to have radius values for arcs and fillets. So I would try to stick with using your radius option that's here. But there's different ways that you can show it. Perhaps I wanted a linear one where basically it's just showing the two different sides from one end to the other of the diameter of that arc that's there. Um, Did it change? Oh yeah, it changed a little bit, which doesn't really give me too many options. So if I go back to diameter, I am given some other options here on the bottom, but I'm actually going to go to radius first. If we have radius, we can choose between some different things. So if we actually zoom in here, you'll see this line. And this really thin line is really just connecting the arc of this quarter circle to where the center would be. So if I move this, you can see that small line move as well around that region. I could, however, get rid of that. So an open leader basically makes it so that it's directly pointing just to that arc itself. Something like a foreshortened is going to be kind of weird. I That's a no for me. I'll typically end up going with things like an open leader, or if it's necessary, a solid leader. But here's basically where we're probably, or where we're really going with this. So custom text position, this allows you to make things look a whole lot nicer. So that's why in a lot of my diagrams, we have things that even if the arrow is kind of at an angle, it's going to at least give it to us straight there. Um, Break lines, I don't really play around with break lines too much. I don't really know what they do that much, but there's probably a time and a place for them. What's also nice is that if there's a specific thing that you want to do to several measurements in terms of its leader or value, you can do that. So if I left click on that and then control left click on all three of these, if I go back to custom text and then hit this middle one, broken leader horizontal text, it does it for all of them. There's other options here as well, like solid, which that is kind of the basic one. It's going to make sure that your measurements are parallel with the angle of the leader. This one will basically break up that line that's there, but have it horizontal. And this one will basically it'll kind of get rid of the outside portion of the leader. Middle one is generally speaking my favorite because it looks nice, it does the job fairly well, makes it so that we don't have to turn our head 90 degrees every single time we're trying to look at a measurement, maximum 90 degrees, or anything of the sort there. So we're doing better. We now know kind of how long the shaft is. We also know what the thickness of each individual region of the shaft is as well. We really haven't talked about the inside behavior of it though. So for something like that, and in addition, which I almost forgot, and you can't even see it on this side, which kind of sucks. On the other hand side, it had that cutout there. So we might want to be a little bit careful with our last drawing because we might need more than one. So I'm going to adjust this just a little bit, kind of give us some room here. And then I'm going to go into my drawing tab. I can either go into drawing or view layout, either one works. But I'm going to go into a section view. So section view kind of gives you a whole bunch of stuff here. So this very first one, or rather these first two, are just designating whether you want it to be horizontal or vertical. So I could cut it like this, but I mean, this isn't really going to do a whole lot for me because it's a solid cross section there. So I'm not actually going to cut it there. If I wanted to do a horizontal one, this one would likely be a whole lot better because then we're going to get specific details about what's going on with both that cutout and the inside portion of it as well. We can also do an auxiliary cutting line, and this just means that we're going to just pick two specific places. So I wouldn't recommend using this too often because I can't interpret that at all. I mean, I can, but it's not easy to do so, and information based on something like this is going to be virtually meaningless. This is kind of harkening back to what we were talking about before, where sometimes you don't want to add specific measurements that are totally irrelevant. There's no reason to do anything like that. So let's just do a normal section, and then we can also do an aligned one, which just allows you to create crazier cross sections, which really isn't that necessary for right now. So I'm going to do a horizontal. Okay. And now we're going to get something that actually looks pretty much what we want it to be. And let's play around with this at least a little bit more. So what I can do, maybe I want this to be a little bit bigger, just so I can see things better. I could do that. One option would be to just bump up the scale on this. So instead I could just use a custom and do like a 1:1. And that's kind of huge. Uh, let's say I wanted to stick with something like this. What I could do is I could do a break view. What a break view is going to do is it's just going to shorten this. It would allow me to cut out unnecessary details of this while still maintaining measurements just fine. If I were to do it for this, I can just say, well, I don't need any information from here all the way to here. It's outside the view in which the break line is being added. So it probably needs to be about like right here, maybe. And then it kind of shortens it a little bit more. So I'd have to do something that's probably kind of like that. So I could do some stuff like that if I want to. It's not entirely necessary, but it does allow me to make things a little bit smaller and focus just on the information that I need. That is one method of going about it. I'm not going to do that. I think I'm just going to get rid of that specific info. So I'm just going to Control Z. And I think I'll just make the scale what it was. So use the parent scale one more time. Because if I want to, I can actually adjust some of this information if I need to. I can kind of expand or make things easier to see if I so choose. So the first thing that I'm going to do is, based upon this, I'm actually just going to dimension this circle that's on the inside. But even more so, I think I'm going to add another, where is it? Center line. That'll give me a bit more information as to how to dimension this specifically, because yeah, I could totally give reference to that, or rather these circles here, in reference to maybe the side, but it's a lot easier if I have a center line going on here. So what I could do, I could just select the outside edge, and then if I select that edge there, then it'll just say that there is a 15 degree or 15 millimeter distance from this center of the shape up to that one. And I don't even need to dimension this one here on the bottom because it's going to be the same thing. It will reflect that exact same measurement that's there. Now I also want to make sure that this is dimensioned properly and that this has some distance from one edge to another. So I could select any of these things, say like this point here, this edge right here, so I'll just do that edge right there. So now we know that this hole here is 50 millimeters from this edge here. It's 15 millimeters from the center line, and it has a diameter of 10. So I'm going to space this out a little bit more, and I'm going to make this look a bit nicer. So I'm going to just control left click on both of those things, go to my custom text position and make sure that they look all nice and pretty. So that's pretty self-explanatory to kind of look at some of those things. The one thing that I'm thinking about right now is that it's pretty hard to determine that you even have something that's a donut shape. I mean, at face value, like you might be able to tell that if you have some kind of cutout going around in here like that, but you might even want a cross section of this as well. So that might be another important thing that you would have to add, possibly a cross section that is in line with this piece. So you can do that as well with a geometry like this. But let's try to do one thing at a time. I think what I'm going to do next is I want to look at some of the details regarding this cutout here as well. So what I'm actually going to do is I am going to do a detail view. So with a detail view, basically what it does is it allows you to just kind of drop a point and circle at a region, and then you get a larger scale view of that specific part or of that specific region of the drawing. So I like to make things look at least somewhat pretty, just so now this is a 1-to-1 scale rather than all of these things being a 1-to-2 scale. So it's a larger scale, as you can plainly see. And now we can dimension things here a little bit better if we want to. We can say that from here to this circle would be 5 millimeters. And this arc in general is going to have either a radius of 2.5 millimeters or a diameter of 5 millimeters. And that makes sense with what we had or what we talked about before, kind of those details that we had when we were actually looking at the part itself. So I'll go back here and I'll just make these look nice. Why not? And for the most part, that's pretty self-explanatory. What I could do as well is I can add some details. So this is one instance where I'd say it's not really necessary to do something like this. I'm actually going to get rid of that small leader. And the reason is because if I go to sketch, I can add more details to this sketch. If I hover over this, there we go. It will show up with the point that's there. So I can actually use that point as a reference. So now I can say, well, from the exact center to the bottom of this, or rather this edge of the shaft, will be 5 millimeters. I didn't have to do that, but those are little details that you can add. There are some details that I kind of glossed over when we were going over Smart Dimension. If I just place this here, where is it? Here it is. So arc conditions. So usually if you're smart dimensioning either an arc or an arc with regard to some other reference point, you can choose specific details about that smart dimension. Let's say I wanted the distance to be minimized, where it would basically be the distance from here to here. So hypothetically speaking, that should be 2.5, which it is, and it lines up where it should, or 7.5, where it's just incorporating this 2.5 measurement with the diameter of 5 that it has. So there's a whole bunch of different ways that you can smart dimension certain things. If I were to smart dimension this part specifically, I likely wouldn't have created that center in general. I would have just selected the arc, selected the respective side, and then just made it like this, just so that it's at least reasonable and easier to kind of interpret it in that manner. Then I'll make this look pretty. I'll do one of those guys, kind of widen it out a little bit. And by and large, if you're looking at a diagram like this, we are fairly, or at least for the most part, assuming that the center of this arc is going to be collinear with this line for the dimension that is being made. That's a good part of the detail view. One little detail about the section view as well. So you'll see here that we have arrows, and we also have the ability to flip the direction as well. So hopefully this doesn't break everything. Okay. Made things a little bit wonky, but not too bad. Basically, this implies right here, the arrows pointing upwards, means that we're looking at the top half of this shaft. So it basically took a knife, cut right through the shaft, and then it's as if we tilted the shaft kind of uh, clockwise. So basically, you're looking directly at the flat face of it now. You're turning it away from you. So then you're able to see inside of it as well. And let me just reapply that dimension there, or rather that center line and the dimension. Center line. Can widen that out. And then we can add this dimension back one more time. And if we want, we can put it up there. Then make it look pretty like that. And then line it up. You'll notice those kind of yellow dotted lines, pretty similar to how we get them when we're just playing around with parts. It'll do the same thing. It'll kind of align things relatively properly. I would probably also, kind of like what we were talking about before, perhaps add some other either cross sections or auxiliary views just to make sure that we're able to see everything appropriately. So this one is kind of just chilling. It's not really doing a whole lot, this image here. So it is helpful to have, but there's other dimensions that we could likely have instead, because if we're looking at it from this view, it doesn't really do a whole lot for us. Sure, we can smart dimension things properly and say, hey, that's 55, and hey, this here is 35, which those are going to be identical to this 35 and this 55, but if I dimension this inner one here, it's probably just going to confuse you, because that's taking into account this 1.5 radius fillet, that it's kind of creating an extra face there. So I guess if we wanted to be more specific about that, if I actually go back to the part itself, really what we're seeing is this circle, which has a diameter of 32, versus that circle, which has a diameter of 35. And it makes sense that it's a 3 millimeter difference because it's uh, 1.5 radius on both sides, kind of shrinking that face inward a bit more. Um, so let's see. Let's see if we can maybe add a little bit more detail to some of this stuff. These should be relatively fine for this view over here. And you might notice that it is saying underdefined. I genuinely don't think there's any way that you can fully define drawings just because they're very finicky. I've tried to read up on it as much as I possibly can, and nothing gives me good details about it. So it's not really something that we need to be that you need to be too concerned about. I'm primarily going to want you guys to be mimicking drawings more so than you are uh, just creating ones on your own. So I'd be hesitant to make a section view out of another section view, but we can, in this instance, do it if we want to. Oh, you can actually do that. Then I can do something like that. So this is just a way for us to kind of get a better idea of what is actually happening here. So kind of remember, if we recall what is going on an image like this, this is really just implying that we have this hatch region being solid, and this hatch region being solid, and this empty region being left open. So this is just a good way of being able to see, hey, we do have some inside region there as well. And we could do a little bit of smart dimensioning. It wouldn't be super necessary, but it certainly can't hurt as well. This one might be a little bit trickier to do just because it might be trying to grab strange dimensions, but you could just say that, hey, if we have something like that, then the inner one is going to be 20 in a case like this. So there is a is that in this case? Yeah, it should be just 10. I don't know why it's so large there, unless I'm just having a brain fart. Probably. So that's a way that you can just kind of dimension on the inside of the shape as well. And we could, if we wanted to, possibly do something identical for these guys as well. Just to make sure that, because from this angle, we can't even see that we have that cutout there. So perhaps how you orient your parts is also helpful as well. If I had flipped this 180 degrees, then doing much to dimension this cutout here, other than that part, other than uh, showing the distance from the edge and the radius of it, that would be plenty. As it stands right now, since I'm not looking at the left view of it, it's kind of harder to tell that that's actually going on there. And that's not to say that I can't add additional views. I can look at it and I can add a left view as well, just for further clarification, just to kind of be able to see, hey, there is something going on here. But I don't think it would be entirely necessary for something like this. After all, this is just kind of more of a demo. Um, some other details that you can also do is you can edit this stuff here down at the bottom as well. So if I actually right click on the sheet, if I go to edit sheet format, you'll notice all my stuff went away, but now these lines are blue. So this is actually pretty similar to just creating and drawing lines. If I want to get rid of some of this stuff, I'm entirely within my right to do so. So let's say I wanted to, I think I can even trim stuff. Yeah, let's say I wanted to just trim away some of these edges and perhaps just get rid of some of that. Like all that garbage. I can just do that. So you can really simplify these sheets if you want to, or play around with them a bit more if you want to. It's not necessary to do so. Sometimes for the sake of room, you might want to do it. But it's little things here and there that you are able to do to kind of make your life a little bit easier there. I don't really know how to create those more bold lines. At least not off the top of my head. If I do something like that. You could just copy them. So something like that, you can kind of work through it. And also in terms of writing notes and such on your drawing. So if I get out of this and then just hit this guy at the top right, it'll just save it appropriately. If I hit it again, should work. Maybe I broke something. There we go. Now it works. So definitely you can add titles to things as well. So two ways that you can just add notes is in the, where is it? In the annotations, you have notes. Also, if you right click and move your mouse downward, it kind of is like a little quick select, allows you to add notes. So here I can just start adding anything that I want. I can change the font, or I can change the size, the color, make it bold, any of those sorts of things. So if I want to add a title to this, so shaft, I can increase the size of that text. Let's do to 36. And if I click out of it, it'll try to get me to place it somewhere else, but I can just hit escape and then specifically move that one there. Kind of like how I add the details on the sheet. So I'll do like units, millimeters, whatever the material is. So material, and then I'll do like AISI 1020, and then whatever the mass is. You guys don't have to do things exactly the way that I'm doing them, but I mean, that's just kind of how I've learned how to do, or how to add certain details to these. So I don't know what the heck the mass is for this object. And then you can just have it anywhere on here. So, I mean, there's myriad ways that you can play around with the sheet itself, playing around with the parts, getting different views of how to actually make these sorts of things. It does take a little bit of finesse sometimes. Sometimes creating some measurements might be trickier than others. Try to look at whatever error it might be giving you if it does. So if you try to smart dimension two things, generally speaking, if it can't create that smart dimension, it will say something. It will give some sort of details regarding, hey, there's a specific reason that this isn't working here. Um, and that can typically either be cause for you to either Google that and try to find them on the forums, or perhaps just let me know, and we'll try to work through what the issue is, and figure out what's going on there. Um, by and large, that is primarily all we have for the lecture and kind of a demo for this stuff. One other cool little thing, I'm not really going to do anything crazy here, but let's just say I like opened this up and did something there, and then I went back over here. It's going to try to rebuild things. So nicely enough, if you have both the part open and the drawing open, if you make you are within your right to make adjustments to the part, and by and large, it will not break things on the drawing most of the time. If I try to get rid of like a fillet or a chamfer, it might yell at me, or it might say you're trying to reference something that doesn't exist anymore. What the heck is wrong with you? Um, but more or less, it should work out fairly well if you try to make an adjustment to one thing on the actual uh, drawing itself, and then translating that back into whatever you might need on the drawing. Um, there's little things here and there as well, like you can adjust the font if the font of your leaders is not big enough. If you go to other, it will use a document font, just kind of the default, but you can also unselect that and then change the font yourself. So if I want a specific measurement to be larger, I could just bump up the units, or I could change the point to something else and then just make it, I guess, smaller in this case, or bigger. So you can really crank things up if it's either important or if it's necessary. Um, I know I made a couple font adjustments on mine, or rather on the in-class assignments for you guys. It's not going to be super necessary for you to do, but if you do want to change those fonts just for practice and kind of play around with different things, see all the different things that you can play around with, that's totally fine as well. I am actually not sure where document font is, but a nice thing is that if you hit this gear at the top, and if I just search document font, or not, maybe just font, and then click on certain things, these are all like the default options for fonts. So I can bump a lot of these things up, or adjust these things as necessary if I want to. So right now it's already saying that the default font for everything is 3.5mm units, or I can change it to point, and then it'll always adjust to that. I can put things in bold or italics, I can change the font, I can make sure that certain things are underlined or strike through. So there's a lot of different things that you can add to your engineering drawings if it is necessary. Um, yeah, that's really all for today in terms of the lecture. Um, there are two in-class assignments. They are not due until I think I put Sunday. I think I put Sunday night. And the reason that you guys have so much time for it is just because I know there's been a lot of technical issues with regard to kind of starting to get things like assemblies uh, and drawings and all this kind of extra stuff that we're doing now up and running. So hopefully that's at least a reasonable amount of time for you guys to kind of be able to get through any sort of issues. Ask me about any sort of issues if you are having any technical difficulties, and we'll be able to sort them out and try to get things working. Um, the homework is not up quite yet. I'll either upload the homework tonight or sometime tomorrow. And you guys will have a little bit of extra time to work on that as well. So, regardless of whether I assign it either tonight or tomorrow, it will be due the earliest next Friday. just so that you guys will have a good bit of time to kind of go through it. For all three of them, so the two in-class assignments that are due, I think, like I said, uh, Sunday, and the homework, I would like for you guys to make those parts. So I've already included the diagrams. Um, I want, or I would like for you guys to make those parts and also make the drawings. So then the drawing and the part, maybe, I mean, there's no need to do like a pack and go. You can literally just save the both of them. So if I wanted to do like these two here, just in this folder, I could do like run demo and then save, and then I can have include drawings. So I could do all this stuff, or I could use the pack and go, but it's for this it's definitely not necessary. Super cool, it's yelling at me. So maybe we shouldn't use pack and go anymore, or as much as possible. Um, but yeah, as long as the part that you make and the drawing is in a zip file and uploaded to Canvas via the assignment upload, that's really about all that you need. Um, I will, and I did make note of this in the announcements, I will post the parts if people are struggling with them, because I think it's a lot more important for you guys to be trying to get practice with the drawings, because it will be relevant later on in the semester when we're doing, I think, both our possibly the second exam, definitely for the project at the end of the year or semester rather. Um, but definitely try to make the parts, because it will be relevant to the project. Since, spoiler alert, I am going to have you guys be making not just a part but several components uh, to kind of create an assembly of something specific. Um, so we'll probably see how that goes later on. Hopefully I can find some workaround for like the pack and go for like assemblies if screws or anything like that are used. But I don't think that that's the issue. I think the issue is possibly the toolbox. Um, Other information would primarily just be I did email, so I emailed some of the other TAs. None of them had any idea why people were having issues with the pack and go. I emailed SolidWorks support, and they basically said that the only fix that they could think about was doing a repair installation. So if anybody is still having issues saving assemblies or doing the pack and go or anything like that, it might be worthwhile uh, to try to do a repair. That shouldn't mean that you need to reinstall. It should mean that really you would just need to go to kind of the installation, um, like SolidWorks wizard, and it should have a repair option in there. That's assuming that you guys even want to do it. Um, I'm going to try my best to make sure that it's not necessary to do that, so that there's nothing that we do here is like super necessary for like the toolbox or anything like that. I'd rather by and large you guys just be either using geometries that we find from some other source or just creating our own geometries, or all make the geometries and you guys put specific things together. Anything of that nature. Just because I want to make sure that this stupid installation issue or the stupid pack and go issue that we were having last week can, at bare minimum, not be a thing. That would be my desire at the very least. Um, does anybody have any further questions about anything? Because if not, then in the meantime, we can pretty much just get started on the in-class assignments. I can just hang around, and if you guys want or have any questions about anything, more than welcome to ask any of that stuff. Like I said, there's going to be a good amount of time for you guys to work on these things, so I mean, if y'all are more than welcome to peace out now if you want to save it for another day. If you do want to get a head start on it right now, you can do that as well. Oh man, dropping like flies. But I mean, I'll probably stick around for maybe about another half hour. We'll see if we can maybe call an earlier lecture today, and then if anybody has any questions about anything at all, whether it be the in-class assignments, whether it be the homework, whether it be grades, or what the heck else is on your minds, we can discuss any of that stuff if you need to.
So for the in-class assignments, just to make sure I understand it right, are we doing our best to recreate the drawings that you did, or do we just need to describe the part well enough that, you know, one could rebuild the part?
Yeah, so
If
good question. I added a little bit more details on the Canvas page, but since most of you guys are here, I'll explain it now. What I would like you guys to do is I would like you guys to recreate the part based upon the diagram that I have given for those two parts. And then I would like you guys to also create a drawing from the part that you made and try to make it look as close to the drawing that I created for you to create that original part. Does that kind of make sense? So really,
yeah,
yeah. So really, the main thing that I'm asking for, requesting, as part of the upload, the submission, is going to be a part that is likely not going to be mine. Um, it could be. I'll describe that in just a second, as well as the drawing for it as well, as close to the original drawing that you made the part from as possible. What I am considering doing, and I think I have it set already, technically the parts are on Canvas right now. You guys shouldn't be able to see them. If you do, then I would be a little bit annoyed with Canvas. But they're scheduled to be published on TikTok on what day? So October 31st at 12 a.m. So that should be tomorrow at midnight, basically. Tomorrow at midnight? Yeah, tomorrow at midnight. So if you are having issues with making the parts and you're just like, I can't, like, this is being a pain, I'm having issues actually making it, it's totally fine. You can just use the parts that will be set to unlock tomorrow at midnight, and you'll be able to start working on it anytime on Saturday and Sunday. And that's why the deadline, like I said, is I'm fairly certain Sunday, like the first. Um, or you can make the part yourself. Um, I would like everybody to try their damnedest to make the part. And the reason for that is because it's just going to make sure that you guys are still going to be sharp when you're making parts. This is typically the part of the semester where I'll be giving you a lot more stuff. Kind of like last week, I just gave you a bunch of parts and you guys were just to put it all together. Um, I would rather you guys be trying to make these parts as best you can and then smart dimensioning them, or rather, and then kind of creating the drawing after. If you end up actually using the part that I made and made the drawing from, I'm I'm not going to be upset about it, I might just like request or like ask that you guys mention it or say something about it. If I dock any points at all, it's not going to be much, just because I want to make sure that you guys are making the parts, but I want you guys to understand how to make the drawings more. So whether or not you can understand the features of all of the stuff that you can do within the kind of the drawing GUI, I'm more focused on that than I am how well you can make the parts. That being said, uh, if you're working and making the parts, and if you are struggling, that'll kind of shine some light on what we need to work on, or maybe specific things that we need to get better at and kind of focus on. So hopefully all that makes sense.
Hey, Ethan.
Hey, what's up?
I was wondering, how did you, so for like that first drawing, just all your drawings, you have the origin.
Mm-hmm.
Um, what can I click to make that happen? Or where can I go?
In the
Because
drawing,
that, in the drawing, yeah, because that's not the case with all of my drawings. I mean, just with the drawing. Did that just automatically happen?
I think if you go in your view menu, that's a good question. I think if you look up at the top right here where you see the eye, if you click the little arrow next to it, you should see the button that says origin. It should be fourth from the
Okay,
top on the left side. It might be unclicked. If you click on that, it should show up for all of your diagrams.
okay,
Let me know if that actually works.
okay.
Hey, Ethan.
What's up?
Okay, yeah, that did work. Thank you.
Perfect, no worries.
For the in-class assignments, is it the thing labeled homework in the in-class assignments folder?
Did I mislabel? I totally did. Hold up.
You didn't mislabel it. It's just you have to click on the assignments tab of Canvas. It's not in the files.
I did label it homework 7.
Okay.
Yeah.
All right.
Let me just adjust that. Yeah. Stupid me. Simple fix though.
Wanted to make sure I wasn't getting ahead.
You're fine. Today's been a fun day. Let's put it like that. So no surprise that I'm making silly mistakes here and there. Okay, that's good. Yeah, it'll say homework 7 at least just for a second here on the in-class assignment, but I'm adjusting it. Oop. Okay, should be correct now.
For dig-
Next exam, let me check the syllabus. I think it's kind of coming up quick. Syllabus says that it is on the 19th of November. So that is going to be not next week or the week after. It'll be the week after that. So 3 weeks from now, roughly. In terms of content, which I assume you might want to know as well, I kind of might have like, it's not going to be as many questions just because we're going to be talking about assemblies. And I don't think that I'm going to include simulations on that one. I think what I might do, I'm trying to think of how we might want to do this. I think I might just show simulations and kind of motion studies to you guys. And then it'll just kind of be like a cool, detailed lecture. And then I don't know if I'm actually going to give you guys a homework for that. because if we're already having some issues with regard to sending assembly files, simulations and motion studies are just going to be an absolute headache for everybody. So I would rather just show you guys that they're super cool and maybe include some extra information that I didn't have time to go through. There's like at least one topic that I realized that it's not on the syllabus, but I kind of glossed over it, or I never really touched on it. So I might just use that kind of final lecture as a time to just squeeze in the motion studies simulation stuff, as well as just like a couple other cool things that are good things to consider. But I'm leaning towards not actually having a homework on that. In terms of like the content for that test, I mean, it's roughly 3 weeks from now or so, so don't expect what I'm about to say to be exactly what it's going to be. But I'm likely leaning towards having one problem, which I'm just going to give you a bunch of parts, and I want you to assemble it properly. And then perhaps a simpler assembly where I would like you guys to make some of the parts and then create the assembly uh, and then submit it. I perhaps one of those I might have you guys do a drawing for, or kind of like replicate a drawing for. I just want to make sure that it's not as like daunting as the last one, because I know the last exam took a while for you guys, or some people at least, and hopefully it's not as immediately terrible as that last one might have been for some people. Do we have to have our annotation scale and settings the same as yours? Scale, try to keep the scale reasonable. Um, in terms of settings, I'm not going to be too crazy about it. So like if you guys want to have uh like changing like the font size or anything like that just to make it more easily readable, I'm fine with that. Uh, I'm not going to be too much of a stickler with regard to scale or anything like that, but I mean, I would say use your best judgment. Worst case scenario, you can just use the scale that I kind of have on my sheet, and you'll kind of know that just by playing around with the settings. Usually, you're not going to need to play with any of the scale ratios that are greater than one, like 2 to 1 or like 5 to 1 or any of that stuff, because then you're talking about massive diagrams, which there should be really no reason that that will be the case for many of the things that we're doing here. So I'd probably just say make sure that the annotations are reasonably readable. Make sure that the overall scale of the diagram is reasonable. And I know reasonable is very subjective, but I would say use your best judgment. So first part, missing a section view. What is the distance from the hollow space to the front and rear faces of the part? Let me look at the part. I probably should have added another, yeah. When I was kind of going through the PowerPoint, I likely should have added another cross-section view just to make that a little bit more apparent, but you're right, and I'm glad that you pointed that out there. So since we are labeling something that, if you're looking directly at it, is just a rectangle, but it's giving you something that is a cylindrical value, then that's implication enough that it's actually not just a square cutout, it's cylindrical. I might update that just because it's not as apparent, but that doesn't mean that it should be kind of ambiguous. So, kind of my bad. How did you get the hatch region on the top view in the second part? Top view on the second part. Oh my god, I didn't go through that. Okay. Well, I'm glad I'm still recording. Cool. So I can talk a little bit about that as well because I'm losing my mind today. I'm sorry, guys. Okay, let me edit this part here, and it'll kind of just, I guess you could say that part's going to be a little bit of a freebie for anybody who's still here. So I'm going to create something that's kind of similar to that. I'm just going to do another hole wizard. I'm annoyed because this is actually really cool. So I'll just make a basic hole here, do that. So now I have a very general hole that's going on in that part of the diagram. So if I go back here, now it's technically showing it on this diagram, but that's fine. I'm going to show it on this middle one here. So we have broken out section. So think of this as just like a partial section, and you can actually do this for any sort of depth you want. So what I'm actually going to do is when I click on this, the first thing that it's going to do is it kind of has that spline set up, like we would normally have in if we were trying to do a spline sketch. So if I just kind of sketch out a region, and it doesn't have to be too exact, it can be reasonably good, something that kind of looks like that. So I sketched out the region, but then it got rid of it. And the reason that it got rid of it is because now I actually have to designate where that even is. So I think if I select this edge here, it's going to consider that to be like the vertical edge. Or hold on. Silhouette. Yes. Yeah. So and this is also good. So when you select that edge, it'll also show other regions, other sketches. You'll see these yellow planes here. That's showing regions where that sketch plane that it's creating actually is. So thankfully, it's putting that sketch region directly where it should be. It's putting it right at the middle. So it's almost like a partial cross section. It's not doing it through right down the middle, or rather it is in this case, but it's only doing it for part of the image. This is something else that I'm not going to be very rigid about because splines are stupid sometimes. And technically, I think you can make other sketches to do the broken out section for anyway. But this is it's just an easy, quick way of being able to do it. So I hit OK. Now I'm able to see just on the inside of this. So it's as if the cross section of that part is only cutting it like it's only cutting like this part of it right there. So it's only cutting out that region of it right there, but not the rest of the shape. That's basically what's going on. Man, I should have mentioned that earlier. It's a cool thing. I think you can also specify, it looked like you could specify the depth. So you can either choose an edge that is relatively self-explanatory where that edge should be, or you can choose or you can just choose like a depth. So I think the other option there was choosing a depth if I wanted to. So for this guy, so if I click on this, I do broken cutout. I think it might even still work if I choose a depth of 10. Yeah, it just wouldn't go far enough. So I would want to even bump this up. Let's say if I bumped it up to say like 20. It's kind of janky. Bumped it up to like 25. Yeah, it does start to actually show it there. So you can do either a depth or an edge, but an edge is typically going to be at least a little bit better because then you can get really nice clean cuts. Yep, no worries. Should have mentioned that earlier.
Sorry to bug you again.
You're fine.
How do you designate where you want the breakout again? And do you need like both the breakout image, like do we need the image where it's already cut in half to get the breakout to show, or
Do you mean the broken out section?
yeah, do we need the whole, because we've got the image with the broken out section and then right above it is the one that's got the whole thing cut in half. Do we need both of them to get the broken out section, or
No. So really all you need, let me look at the diagram one more time. Okay, I see what's going on. So the bottom one is actually a little bit different in terms of its detail, because if you're looking at what's happening between those two, they're technically not even the same orientation. One of them is looking on it dead on, and you can tell that by the dotted line on the far right, and the top one is looking at it straight down because that slot on the right is now in the center. So the option that I'm using there is, it'll make sense if I click on this one instead here. So if I click on this one, if you look at your display styles, some of your display styles will give further information. So I'm using the one for that one that is hidden lines visible. So this is actually also pretty good information. I could actually like just have it on something like this or on something like this, and it gives a lot more information about what's happening on the inside there. So technically that broken out or that what is it, hidden line visible is just a good way of being able to see other geometry that you might be missing if you're not looking at it immediately. So that first picture, the one in kind of the middle, there's actually no cross section that's even going on there. It's just a front view where you're looking at it and you're saying, okay, there's other stuff happening here. I can't actually see what's going on here. I don't necessarily need a cross section, but I know there's further detail to this figure than what meets the eye. The top view, um, both in name and location, that's both showing more detail specifically about that screw hole, just based upon the cutout, but it's also allowing us to see the kind of that slot on the far right as well. So for something like this, having a cross section isn't even necessary. Um, and that's why I only did kind of that partial cutout on the far left. So I guess kind of what I'm getting at here is don't actually mistake the cutout on the left to be a full cross section. You probably could do some kind of a cross section of it, but it would be pretty janky, and I can't really think of a good way of doing it right off the top of my head. So you'd likely want to use just that broken out section view of it, and like how you orient it doesn't matter. I don't care how it looks. Like it can be something like that. Whatever. Yeah, it can look something like that. It doesn't have to be very specific, so long as you're able to kind of see what's going on the inside there.
sounds good? Thank you.
Cool. No worries. You do want to be a little bit careful here because what I did there was, since this was the main one that all of those other diagrams were being derived from, now all of these also have that wireframe option. So I can technically go to these ones and just say, well, maybe I don't want that hidden line wireframe to be apparent on some of these, but maybe I do it on a couple of them. So you do have a lot of power to be able to pick and choose which specific options or measurements you want on different parts. It can be helpful.
Like properties for a part or an assembly.
Yeah. So I don't think you can do it in. Yeah, you're not able to do it in the drawing. You want to do it for the part or assembly itself. So if we go to evaluate, it'll be the top right button, mass properties. So it's just top right in relation to the evaluate tab itself. Just hit mass properties. I don't think this is showing up on your end. I don't think this window shows up for you guys on the stream, which is stupid. But there should be a little window that pops up and it will give all those details. Center of mass isn't really too useful for individual components. Mass is just because mass is not going to change for a specific part, but for the center of mass, that's really only going to be relevant for assemblies. Just because since there's so many different parts, you want to be able to create a frame of reference that is the same for all of them, and then you can form or find out what the center of mass is. But for individual parts, only the mass is really necessary. Yeah. And I know I've mentioned this before. I think I mentioned it before the exam as well. The mass and those sorts of details, like obviously material is helpful, but having and being able like specifically to check the mass properties is not just important for me, but it's also important for you guys as well. Because it means that if you're looking at what I made, and then you look at what you made, and there's some discrepancy, then we can say, okay, well, what went wrong? Let's actually take a look at maybe certain things. What did you do that I didn't do, or vice versa? And we can kind of play around and see certain things, look through the sketches or what have you. So it's not just something to get points or get points docked. It's also a very helpful thing that allows you guys to kind of cross-reference or verify your own models. Maybe. I don't know yet. I think I briefly mentioned that I might do one. I need to consider what I would make, or rather have you guys do to kind of make that reasonable. I mean, if we get enough time near the end, feasibly we could do maybe a what is it? I wish my brain would work right now. Like a simulation type extra credit thing. If I'm being entirely honest, I need to refresh myself on how simulations work on SolidWorks because I don't use SolidWorks for any of the simulation stuff that I do for my grad work. But I know that it's pretty intuitive for the most part, so it shouldn't be really too bad. If we do any of that stuff, like I said, I could possibly make an assignment out of that. That's really the only thing that I can think of that would be like probably a pretty good extra credit assignment. And I think for something like that, it would be more about playing around with stuff and participating and participation of it as opposed to specific results. The thing with numerical softwares and finding numerical solutions to like geometric simulations that you can make is that constraints and how you orient things are everything. So a lot of the time, if you like, I might run the exact same simulation twice, and I'll get very similar but slightly different results. So one of my results, if I'm Like if I'm doing some kind of like a cantilever, like if I have a fixed end of a cantilever and then I have a force on the very end of that cantilever, then even if I'm using the exact same measurements for everything, if I rerun that simulation twice, or maybe delete the results and then rerun it again, I might get slightly different results. It might be like a difference of 3.01 and 3.02, but it's not always exact. So sometimes there is a little bit of leeway. Sometimes the results are even more different than that. I'm not sure why my dimension annotations aren't correct. The 3D part is fully dimensioned with the correct dimensions. However, I am not getting 60 millimeter diameter or 30. I am not sure. So that's for the very first one. I would perhaps, at least right off the top of my head. Okay, so one thing that I am noticing, be careful of the shape of, so I think we've already talked about it at least a little bit, but we have established that the shape that's on the inside is a cylinder. So this is a square with kind of like a chipped piece on the edge, and it's a cylinder on the inside. So if you are just doing even just a basic smart dimension, it should even register that that should be a diameter of the thing, even though from a two-dimensional standpoint, it only looks like a rectangle. So I'm curious if perhaps the details of your geometry are correct. If that's the case, then we might want to look at some of the base sketches in relation to other details. Like, say, is the sketch actually in the correct place and orientation? Does that even have a length on the inside? Oh, jeez. I was terrible with this. Here, I'm gonna uh, make that diagram look a little bit better. Because I'm realizing more and more that mine looks terrible.
Hey, Ethan, I'm running into the same thing with the dimension. I think what's going on,
Mm-hmm.
because I'm playing now, I think what's going on with him is the same thing that's happening to me is when we entered, then it'll give you a different radius because you're not in the dead center of the cylinder cutout.
So, and that's kind of what I think it might be. I think it might just be a tolerance issue. What I would do is here, and I think I have the diagram up right now, so I'm just going to add a couple more details to this just to make it a little bit more intuitive, and you guys can just do things as necessary or kind of interpret it as necessary. And I'll make sure that it gets revised uh, on Canvas and on the actual sheet itself as well. So I'm just going to make a section view. Hopefully this should alleviate some issues. So from here to here it should be 60. From here to here it should be 90. Which makes sense. It should be just in the dead center of this thing. With how much of a distance? With a distance of 150. So I'll put that, say, like right there. I'll put that right there. Okay. Now we can't see what the heck is going on here. Super cool. Okay, that should be a bit better. Then I'll re-upload this file here in just a sec. I hope I'm not missing anything else. I don't think I am. That's what I get for not making my own geometry. So 60, 30, section view the other way. That's okay. I don't know why. That's strange. You can also play around with kind of like the different ways that you're dimensioning arcs as well. So remember how if I go back over here to where we have something that is kind of like an arc surface, say I'm trying to dimension this the circular cutout, I can go into leaders and I can dimension it either from the center, which is default, but I can also dimension it from the minimum value, which is literally just from the edge to the closest point on the circle, or the furthest point on the circle. So those are little details that you should also just be mindful of when we're looking at certain diagrams and kind of playing around with them, making drawings for them and some such. That's weird that when you turned it, it made adjustments. My guess is just that I don't know. I was gonna make a guess, and I don't really have a good guess. I mean, just looking at it, it looks about the same on both sides. The only thing that I can possibly think of is that maybe for that very first image, Nathan, the cross section was just like a hair off. Because you can see it's supposed to be 60 and 30, and yours are less than less than a quarter of a millimeter off, less than a tenth of a millimeter off for one of them, or less than a hundredth rather, or less than a tenth, excuse me. So I mean, I'm guessing it's either just a rounding error, or the cross section was just very slightly off, or SolidWorks is just losing its mind. All of these are very, very applicable options.
Hey, Ethan, how did you rotate the text so instead of going up and down, it was horizontal?
Yep, so if you want to do that, this one's a perfect example. So if I just click on the measurement so that I can get all the dimension information open, if you go to the second tab, middle tab, leaders, at the very bottom, or near the very bottom, you should see something that says custom text position. If you click on that, it should automatically open up the menu. I always like the middle option, that gets it to be horizontal. I like always use that one just because it's the most visually appealing. Okay, that's awesome. So on the upload assignments tab for the in-class assignment, it should have updated. So if any of you need to re-download it, it is up now with the correct measurements, or rather with more details.